Hi guys, this is going to be a very quick introduction to rectangular versus polar coordinates. So we are used to seeing things in rectangular form. And rectangular form would be something like if we had the ordered pair 3, 4, we would know exactly how to graph that. 3 represents the distance in the x direction, and 4 represents the distance in the y direction. So we're going to go over 3, and we're going to go up 4. And there's our point, 3, 4. So rectangular coordinates, we've been working with those since 4th grade. Now, the cool thing about rectangular coordinates is I could draw a triangle using this. If I make my triangle coming out of the origin like I always do, this distance here would be r. That would be my radius. This distance here would be my vertical component, which is 4. And this distance here would be my horizontal component, which is 3. And of course, this is a right triangle. And knowing this information, if this is theta, 1, I could figure out what r is, and 2, I could figure out what this angle is. So knowing this information right here, I could figure out that r squared is our horizontal component, which in this UV coordinate system, we normally say u squared plus v squared. So r squared is 3 squared plus 4 squared. So r squared is 25, so r is 5. So r is 5. We just figured that out using our right triangle trig, using the Pythagorean theorem. Now we could figure out what this angle is. We could figure out this angle in a lot of different ways. If we were just given the 3, 4, we could have done the inverse tangent, which would have been 4 over 3. Because we know r as well, we could do the inverse sine, which is going to be 4 over 5, or we could do the inverse cosine. Any one of those things is going to get you the angle. All of those are going to give you theta. So we could pull up Desmos and we can figure out, okay, what is theta going to be? Of course, I want theta to be in terms of degrees right now, just because degrees are a little bit easier to work with. And so we're going to say the inverse tangent of 4 over 3. And that is 53 degrees. And 53 degrees makes sense because 45 degrees would be 4 over 4. So we're pretty close to that. So theta here is 53 degrees. Now we figured all of that out using the rectangular coordinate system. Polar coordinates are a little bit different. So rectangular coordinates are always in the form of x and then y. Polar coordinates are always in the form of r and then theta. And we just figured out all of that information here. And so we could rewrite this in terms of a polar coordinate. Well, r was 5 and theta is 53 degrees. Now, the way that you would graph that, r is your radius. That's how far out you'd go on a circle. And so when you're looking at this polar coordinate system, you will see that the polar coordinate system is a circle. And each one of these circles is a different radius. So the closest one is a radius of 1, a radius of 2, a radius of 3, a radius of 4, and a radius of 5 is right here. So this is our radius of 5, that circle around here. So that's our radius of 5. That's how far out our ray is going to go. And then we need to go to 53 degrees. Well, if we look at this ray right here is cutting it at 45 degrees. So 53 degrees is going to be a little bit further than that. And so right here, this point is going to be right there. And of course, we could erase all of the stuff on the outside and just leave the point. I guess I don't know how to erase that with just leaving the point. And there is our point right there in this rectangular coordinate system. And you will see it matches directly up with this. So why? You've worked with this rectangular coordinate system your whole life. Why in the world would we throw on this rectangular coordinate system? And the reason why is because now we can start writing functions, not just ordered pairs, but we can write functions in terms of r and theta, and we can make functions that are circles. We can make functions that ordinarily would not pass the vertical line test using r and theta. And then, of course, if we're going to be writing functions in terms of r and theta, we want to know how to graph those ordered pairs. And so this is our polar coordinate system. This is the rectangular coordinate system. And a quick recap. In order to transfer from rectangular from x, y, and we want to go to r theta, to get r, r equaled the inverse tangent of y over x. R equaled the inverse tangent of y over x. No, R didn't. What am I talking about? Theta equaled, I hope you guys caught that. Theta equaled the inverse tangent of y over x, and R squared equaled x squared plus y squared. This is very important information. Put that in your notes, put that in your brain, and try to remember that. So that was a very quick introduction to rectangular coordinates and polar coordinates.